Hey guys, this is AC Service Tech, and today what we're looking at is the refrigeration cycle, all right? And we're looking at subcooling and the importance of superheat. All right, so we're just going to do a quick rundown on the refrigeration cycle, and then we're going to go ahead and get started. So what you have is you have a low pressure, low temperature vapor coming into the compressor, and then high pressure, high temperature vapor coming out at its hottest point. All right, then it enters into the condenser coil where it starts to reject heat until it becomes a saturated state where vapor and liquid both exist. After that, it then rejects more heat as a liquid. Okay, it's out of its saturated state, turns into a liquid, and then continues to drop in temperature until it comes out past the valve. That is called the subcooling there. All right, the temperature decrease in liquid form. All right, it continues to go through the refrigerant line until it goes through the filter dryer, which absorbs any moisture in the refrigeration system, and then it hits the metering device where there's a pressure drop. It drops from high pressure, high temperature liquid refrigerant to a low pressure, low temperature, 80% liquid, 20% flash gas, but mainly liquid. After that, in the evaporator coil, as it absorbs heat, it then turns into a saturated state in the middle of the evaporator coil. All right. After it turns into a complete vapor, right after the saturated state, after absorbing heat, right where it turns into a vapor to where it comes out of the evaporator coil at, that's called the superheat. It's the temperature increase in vapor. All right. It then continues to proceed over into the compressor as a low pressure, low temperature vapor, and the process starts all over. All right, so why do we need subcooling? All right, the subcooling is needed, which is the temperature decrease in liquid form inside the condenser. All right, you need subcooling to make sure that when the liquid finally gets over to the metering device, it has complete liquid and there's no vapor present. If there is vapor present, it's not going to be very efficient, okay? It needs to be a very, very high or very far spread apart pressure drop, all right? The molecules are all actually spread apart in the evaporator coil when you reduce the pressure, but when you have the high pressure, high temperature liquid refrigerant coming to the metering device, all the molecules are packed real tightly, okay? So it helps reduce the pressure, all right? When after it goes through the thermostatic expansion valve, the molecules are all spread out, all right, and then the temperature becomes much lower. All right, a very easy way of remembering what superheat is it's the temperature increase in vapor form in the evaporator coil. All right, you can simplify it down to that. All right, because there's only one spot where there's vapor in the evaporator coil, and it's after the saturated state, and then you're taking your temp reading and your pressure reading potentially right after it gets out of the evaporator coil. You know, we usually don't have ports there right after the evaporator coil, so we're taking our reading as a total superheat out at the compressor. But basically, superheat is the temperature increase in vapor form in the evaporator coil. Okay? The condenser, that's where we have subcooling taking place at. And subcooling is the temp decrease in liquid form in the condenser, okay, to where it comes out past the service valve. That is subcooling. So there's only one spot where there's liquid in the condenser coil, and it's after the saturated state, all right, where it comes out at. We always take a temp reading right next to the service valve because that's where we can get an accurate pressure reading at. So that is a subcooling. Subcooling is the temperature decrease in liquid form in the condenser coil. All right, we measure it at the service valve. So that's I just wanted to kind of simplify that for your thought process and trying to memorize what is superheat and what is subcooling. All right, subcooling is used to check the refrigerant charge of a system with a thermostatic expansion valve. All right, so you're actually measuring the temp decrease in liquid right at the service valve of the outdoor unit. All right, that is actually not only just giving you the temp decrease in liquid form, but it's actually also giving you a certain amount of volume of liquid in order to make sure that you have a steady column of liquid going to the thermostatic expansion valve. All right, now superheat is very important. right? You have to have superheat. Now, a thermostatic expansion valve will actually control the superheat by itself on its own, all right, as long as the refrigerant charge is correct. And the superheat is a temperature increase in vapor form, and you have to have superheat, which means that you're guaranteed to have vapor as far as it going into the compressor. If you have superheat, you know you're going to have vapor going into the compressor. If your superheat is 0, then, or even 1 or 2, by the time it gets to the compressor, there potentially could be some liquid getting into the compressor. So in the case of a thermostatic expansion valve, the thermostatic expansion valve is actually going to be controlling the superheat. But in the instance of a piston or an orifice or a capillary tube, you need to check the refrigerant charge in superheat. Okay, so that's done right at the valve, typically by the compressor, and we're checking the total superheat. Typically, we're not getting a port right after the evaporator coil to check just superheat. We're checking the total superheat at the compressor. All right, so depending on the day, you know, whether with the temperature outside and the wet bulb temperature inside, on one day it could be a very high superheat, a very high target superheat that we have to set the refrigerant charge to. On another day that's cooler outside and cooler inside, and it's less humidity on the inside of the building, then you know the target superheat that you're setting it at would end up being lower. So you have to set it to the outdoor temperature and the wet bulb for that day on the target superheating chart. You know, you need to set that superheat correctly so that on a cooler day you don't have liquid getting into the compressor. All right, it's a big deal. All right, the other thing is just efficiency. So you want to make sure that you are finding the correct target superheat before you set the superheat. All right, so the superheat is actually the temperature increase in vapor form, and it's set typically at the service valve right next to the compressor as a total superheat. You can check out some of my other videos in reference to how to find the target superheat because it's not on the rating plate like the subcooling is. All right, but if you do need to adjust a charge on a system that has a piston capillary tube, that you're going to have to set in superheat and make sure that you get it very close to the target superheat so that for efficiency's sake and just to make sure that you do not have any liquid getting into the compressor on, say, cooler days and less humid days. All right, hope you enjoyed yourself, and we'll see you next time at AEC Service Tech Channel.